Welcome to this episode on data visualization, part of a series of short films supporting courses I teach in data science and artificial intelligence. You can find more by following me on LinkedIn or as @Binocularity on Twitter. Thank you for watching. I'm going to talk to you today about exploratory data analytics. It's a topic that came from work in the 1970s when statisticians started to think that they needed to understand data before they formally analysed it statistically and mathematically. What's the visualization process and what's its role? What's the real reason that people want to visualize data and data products? The visualization process itself, often described using this slide here. The picture shows the cloud. Data streaming from the cloud to a display system, which includes a computer and a rendering system that generates the geometry and the materials and colors that are then used to draw the picture on the screen. The picture on the screen is transmitted optically to a person. The person sees it, perceives it, understands it, and that generates ideas in their mind. And the goal in visualization is to go from data to ideas efficiently and accurately, and to try and support understanding and decision making. One of the challenges in modern visualization is that the data side of this is growing, endlessly growing. Every day there's more data, whereas the human cognition and perception side is fairly fixed. And although our understanding of human perception and cognition changes, the inherent capacities of the human system remain pretty much the same. So there are a whole range of roles that visualization can fulfill, and three of them are communication, confirmation, and exploration. Communication, often used in entertainment and learning to describe and explain ideas. Confirmation is more monitoring systems. Imagine very large desktops or control rooms monitoring wind farms or monitoring traffic systems. In Newcastle we have the Urban Observatory, which brings back IoT sensor measurements about the city. And then finally exploration, where you're looking into data to find out what's there, what it means, what questions you can ask of it. And we very often get data presented in this way. Just here's some data, not just what does it tell us, but what questions can we ask of it. So you should remember visualizations are always created in a subjective context, and they're images that are interpreted by people, and people are influenced by aesthetics, by the social, cultural, emotional, and epistemological context, their belief systems around data and about data understanding. Visualizations are not transmitted to other computers for computer readability. They're transmitted to humans, and that brings with it a number of things which we'll go through in terms of responsibilities and influences from humans on data content. So this is the IKW pyramid, which is not necessarily accurate, but is a conceptual pyramid around how data goes through information and knowledge to wisdom in humans. And data tends to be things like symbols and signs that represent something in the real world. Information is more structured, with clear meaning and purpose. Knowledge is that information understood by humans, and wisdom gives you this longer term framework within which you understand new information, principles and values that inform your decisions and understandings. The goal of many people with data is to highlight information that generates knowledge and supports better decisions using wisdom. That kind of describes the process. So why use data visualization? Well, Pestalozzi in about 1800 said, "Visual understanding is the essential and only true means of teaching how to judge things correctly. The learning of numbers and language must be definitely subordinated." He created a teaching system that was used in Swiss schools, and you might think, what's this guy from 1800 really telling us now? It turns out that his methods were used to teach Einstein, and Einstein found the visual approach to learning extremely effective, and throughout Einstein's life, he said that he had to see something in his mind before he came up with the mathematics for it. So he had to visualize his theories first. More recently, John Tukey in the 1970s came up with the greatest value of a picture is when it forces us to notice what we never expected to see. And that's this: here's my data, what does it tell me? If you can come back from that with things that people didn't even begin to expect that they could ask from their data, that really encapsulates that. For me, visualization is a tool and it supports faster, more accurate cognition. It's about perceiving and understanding data more quickly and more accurately than you might otherwise. In fact, sometimes at all, because you're not always able to look at a spreadsheet or a set of files and understand from that anything very much about them at all. But a visualization can tell you more. In the real world, Hal Varian, Google's chief economist, said in 2009 that the ability to take data, to understand it, process it, extract value from it, to visualize it and communicate it is going to be hugely important in the following decades, because we now really do have essentially free and ubiquitous data. It's a good question whether you now have free and ubiquitous data. You have personal issues, privacy issues, cost issues of finding and mining data, but the idea here is that visualization is a key part of the data science, data engineering process, and that is indeed true and becoming more so all the time. I feel some of you are not convinced yet. So here's a table. It shows triglyceride, that's related to cholesterol levels, by gender, age and income. In just 5 seconds, just tell me which gender or income group shows a noticeably different effect with age. Okay. You may have the answer, you may not. Here's a visualization of the data. It's the yellow group. Looking at the key, that's females in the low income group. So visualization, when properly done, can give you an insight into the data in a way that a table can't. Sometimes you need tables. When you need a number, a specific number, and you want to understand the number itself, you need a table. But at other times, when you're looking for patterns or trends or outliers or anomalies in data, visualizations really do come into their own. Exploratory data analysis. So this is the concepts that Chartjunk came up with. He in the 1970s described box plots, and he understood that very often questions and answers about data are not well defined. And so even before computers, he was drawing plots of dots and lines and sketching out data to understand what was in there before he started to do statistical analysis on it. And he invented this box and whisker diagram, and there's a whole range of variations on this now, but it represents a mean or a median, a range around that, and then outlier ranges around that too. A quick visualization to summarize data sets. Some of the earliest work was done by William Playfair, who talked about trade balance and money and trade flows between England and elsewhere. And there's a sort of a stream diagram on the left and a bar chart on the right from about 1786. More recently than that, Florence Nightingale famously came up with her visualizations of deaths in the Crimean War and how there were more deaths in hospital than on the battlefield, and then used that to persuade people to improve hygiene standards in hospitals. So data today is still now is collecting in these huge lakes of data. It might be harder to get to them. They may be more private, but they're still there. And very much like oil, it needs exploring, it needs mining and refining for it to be a useful commodity to decision makers, whether it's decisions about physical real-world processes such as mining or car manufacturing, or whether it's decisions about company data flows, company profit flows. So I want to talk about both some of the bad things and good things in visualization before we come to an end. So Chartjunk is something Edward Tufte introduced as an idea, and it's a great concept that there are things on charts you just don't need. And in the case of the diamonds graph here, not only are the things that you don't need, but nowadays this wouldn't be viewed as an appropriate way to present data or images in general. However, what he was saying was that you should minimize the data ink on a page and that you should do a very sparse line graph rather than a more complicated graph with ink on the page which didn't represent data. So my colleague Michelle Borkin, at the time at Harvard and now at Northwestern University, investigated this, and she found that visualizations that were very sparse, that just showed the data, were not as memorable as visualizations that added additional natural-looking objects to the scene, like the apple graph on the left with the apple on it. People use that as a cue to remember the more abstract data in there in some way. And so she argued that actually you should be using some form of annotations that are not strictly data to improve memorability of visuals. Another problem in many visualizations, and we've seen some of this during the COVID outbreaks this year, is the lie factor. The lie factor is how much is the size of an effect in a graphic representing the size of the effect in the data. And you would think it should be one-to-one. The size of the effect in the data should be the size of the effect on the page in the graphic. Well, here, showing fuel standards for cars in America from 1979 to 1985, it looks like there's a huge change. So is that true or not? Well, if you actually measure the real change, it's about 15 times larger in the graphic than it is in the data. So that directly represents a visual lie. And that's something to try and avoid, to try and make sure that when you do visualizations, they accurately represent the data. So what kind of things work? Well, we know simplicity works, that very straightforward visual messages are good. This is a bar chart of all the presidents in the United States over time. They were 100% male, 100% white, 100% Christian. Obama came along, there's a little glitch in the graph at that point, but Trump got these things back on track again. And Robert Kursara at Eager Eyes created this. And it's not till you see data in its context always that you understand the message. And here the message is possibly not surprising if you think about all the US presidents, but it's quite worrying if you think about a multicultural society. Another great graph about climate change was Al Gore in his film An Inconvenient Truth, and he showed how over time CO2 concentrations had stayed, although varying, relatively the same up until the Industrial Revolution, where they've shot up within 45 years. And not only did he draw the graph, he actually plotted it on a big projection screen and used a cherry picker platform to go up as the graph was drawn and to show you just how much higher CO2 levels are than they have historically been. So what are key points of exploratory data analysis? We've got roles of visualization. It can be for communication, it can be for confirmation, it can be for exploring data. And exploring data very often is the first point at which visualizations are applied to data sets. And this exploratory data analysis almost always is the thing you do before you run some mathematical tools on your data. Simplicity in visualization, clarity is a key thing. Use the ink to show the message, figure out what the signal in the data is and show it. To conclude, what's the value of information? And this is Philosophia, philosophy, friend of wisdom. And this is a quote from T.S. Eliot in 1930, amazingly, who said, where is the life we have lost in living? Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? And nowadays, you almost certainly should add, where is the information we have lost in data? So I shall leave you with that, and we'll be back soon with more details on visualization.